My name is Kevin Markman, and I come to you from New York to talk a little bit about taking web apps offline and what it takes to do that and how you can do that. Because realistically, your app isn't there for your users unless it's available to them all the time. So first, I want to tell you a little bit about me and my background. I come from a history of C++ desktop applications, and they had the exact opposite problem. So the issue they face is that they didn't get any of the advantages that the cloud brings to us JavaScript, HTML, CSS people, and that is the update cycles were years. A product that I worked on 3 years ago still isn't launched. I've launched more in the last month than I've launched for my previous job, which is kind of crazy. So at the same time, there are things that desktop apps do well that web apps suffer with. And one of those things is offline. And Docs Offline was a huge effort, and it really pushed the boundaries of what's possible. And by taking this step forward, I think what we're really showing the community at large is that it can be done. It can be done for you. So first, what's Docs? Who here has used Google Documents by a show of hands? That is fantastic. That's pretty much all of you. So I should be able to skip through this quickly, but I do want to give a high-level overview. So what Google Docs used to be a couple of years ago is content editable, which is basically a text area into which you type, it puts it all into HTML, it would send it up to the server would store it as HTML, and that was bad. That was bad because the model, the view, the controller, they're all the same thing, basically. You can't have your model and your view both be HTML. So what Documents is now is it's a full-fledged word processor. What you see on the screen was placed there explicitly. You can have tab stops, for example, in HTML. We placed that text explicitly. The cursor, for example, is just a 1-pixel wide div which blinks on a timeout, on a timer, right? So when you click into the document, it explicitly positions that div in that location. Everything is done in JavaScript. So that's really cool, and that really enables offline web apps. The number one thing that you need is you need everything to be done on the client. If your app depends on constant server communication to get all of its information, then you're gonna suffer. So we started off in the right place, but there were still a number of things that we didn't do. So what used to happen 2 years ago, Docs would connect to a server and pull down a huge chunk of content. And that includes the model, the application itself, meaning the JavaScript, the CSS, etc., and along with all the configuration options. And that completely breaks MVC. We're bundling it all together. So why do we do it? For performance. But obviously, or as you'll see, we will have suffered because of this. But what's really nice is that after this one chunk, there's only little things being sent back and forth to the server. The client really does the heavy lifting here. So that means that if you have a really laggy connection, it doesn't matter. You can continue typing away, and after that connection is restored, it will all get sent to the server. The server is really just a persistence mechanism. And the client is there for everything that you do. That really enabled us to take offline to the next step in the sense that we already had this infrastructure from our real-time collaboration built into our app. So what is Docs like now? As you see, there's no separation between server and storage. To us, server and storage are sort of the same thing. When we pull the document from storage or server, it doesn't matter. So let's walk you through at a high level what happens. So first we have this happy user, and he types in docs.google.com. He types in a specific document ID, either by bookmark or using the Drive launcher. And from here, Chrome triggers the fallback application because we don't have a network connection. Let's assume we're offline now. The online flow is largely unaffected. The fallback application takes them to a place which determines which binary to run, and we'll jump into this in a second. It determines which binary to run which Java and CSS to pull in, determines that the doc is available, and then sends the user to the docs themselves, to an offline specific binary. That offline binary then reads the document and user data from the database and uses that info to load the offline document. Oops. We then use browser history APIs to rewrite the URL to make it look like it were the online binary. So why is that important? We don't want to surface to the user that anything is different. Everything should look identical, including the URL. As a matter of fact, if you hit refresh, it uses the current URL in the URL bar, so it will actually go through this entire flow of hitting the fallback application, figuring out which binary to use, ensuring that the document is available offline, etc., if you don't have a connection. So as the user interacts with their document, as they're typing stuff in, it gets saved. It gets saved both locally, as you see in the first part, and then down to the server. What we store locally is pretty much identical to what we send to the server. And that's done so that as we read it back, it's exactly what the server is sending to us. So this works really well. Except this only talks about one document. So what can we do to really push this out? Because we have lots of documents that are offline. We have what's known as a shared worker. This is actually a JavaScript shared worker, which we synchronize all documents with in the background. So there's a locking mechanism, which I won't go into in this talk. It's an entire talk in itself, to ensure that nothing gets written to storage by multiple tabs at the same time. But every single docs tab that you have open has a pointer to the shared worker. So the way JavaScript shared workers work, as soon as you close all tabs that point to them, the shared worker dies. So we also do one last bit of magic, which is a background page. This background page is a permission that's granted to us through a Chrome app, which is why we ensure, or we force you to install the Drive Chrome app before you can use offline. And it's really there for that permission, because if you're typing offline and you close your tab and you have Chrome open or you have your computer on, and a couple of days later you still haven't gone to docs, you really want that content available. It would be crazy if it weren't there. So let's drill down a little bit. I want to talk about two things which were, I think, the really novel parts about docs offline. So the first one is how we manage loading. So I talked about choosing binaries, the fallback application. What does that mean? And the second part is matching static data. And these two things really came up as we were developing. We didn't envision them beforehand, especially the matching static data. And that's a really, really interesting one. So I'm really curious to, I'm going to ask you guys a couple questions there as well. So first, we're going to talk about managing offline loading. I first want to talk about the application cache. Who here has used an app cache in their applications? Awesome. Great. So I'm going to go over this really quickly. Basically, an app cache allows you to store static data on disk. You reference it through the HTML tag. You say the app cache manifest points to this file. It's just a blob that looks like this. It has an explicit section, network section, and fallback section. Explicit section says, if I hit this URL, always use what I have available locally. Network says, if I hit this URL, always go to the network. And the fallback says, if I don't have a connection available, then fall back to this. So what was the difficulty with docs? One of the things that is unique about docs is we don't have just one binary. We have several binaries. So for example, we have apps for domain, and people can choose to enable or disable experimental features. That leads to different binaries, but we can't determine that from the document URL. So as the user types in the URL, hits enter, they're offline, we have to pick the binary based off that. App cache does not provide us a way to do that. There's no code that can run. There's not even regular expression matching in the explicit cache entry. So instead, excuse me, instead, what we have to do is we have a fallback application. So this syntax right at the bottom says that if the user goes to anywhere on docs.google.com, so docs.google.com.blah, it goes to the fallback location instead, which is also an explicit cache entry. So let's actually step through an example of this. So the user puts in the URL or clicks a link to it, whichever way they get it. The application, Chrome decides that there is no network available, or the server responds with a 400, whatever forces it. And it says, hey, look, there's a fallback location for this. So from there, it forwards to the fallback location. The fallback location takes a look at the URL, which is in the URL bar, and it tries to interpret a few things. What does this point to? Does it point to a document? Yes, it's pointing to a document. Does the user have permissions for it? What kind of binary do we need for it, etc.? It's the one that actually does all the processing by looking at the URL and making decisions from there. And that's the way that we can actually intercept it. If those aren't available, if the answers to those are no, you don't have the binary, or the user doesn't have permissions, it blows up. If you do, then we pick the binary and we forward the user there. But there's a catch. There's no way to really communicate with the binary. So if you have an application cache and you have an explicit cache there, everything, including query params, have to match exactly to hit it, except hashtags. So hashes allow you to add information after a URL. It will still hit the correct app cache manifest if it's there before the hashtag, and everything afterward is ignored. So we encode a bunch of stuff after that hashtag to relay that information from the fallback application to the editor itself. So that way, we can encode the things that are on the landing page of the editor, which weren't there, which are there on the online flow, but we can't get at immediately. So another thing that we noticed, for example, is that it's slow to read. We use IndexedDB. It's slow to read IndexedDB while things are loading because the async callbacks come back asynchronously at a time in which you can't determine. So if a large JavaScript binary came in between, it takes forever to get the callback, and you can't have that. You really want a snappy load. So from there, we parse the URL, we extract out the doc ID and whatever other things are in the hashtag, and then we rewrite it using the browser HTML5 history API. And that's basically our initial load flow. So that worked really well, except we bumped into this issue, and we really only came up on it infrequently, but it was affecting more and more users, and we couldn't really figure out what was going on. So CSS and JS bundles have to match the landing page. The landing page here is just the HTML page that's served. So how does this come up in practice? Does anybody have an idea of when the JavaScript and the HTML page wouldn't match? So this comes up. So first, let me tell you why they have to match. So our HTML landing page actually points to a JavaScript binary that has a hashtag attached to it. So for example, we have the HTML page refer to my JavaScript binary 123. And that ensures that the APIs that are used between them are identical. So why is this a problem? So let's actually step through this and try to see when this happens. So there's a level of indirection that's added by the app cache. So the user requests the app cache manifest from a given machine, from machine A. And that app cache manifest says, OK, so your HTML page is /page, for example, or /edit for documents. And here is your JavaScript binary, etc. That's fine. The user's happy. Everything's good. And then the user goes to actually fetch that. So first they go to fetch the hashed static content. So they go and fetch my JavaScript binary 123. Perfect. Not a problem. And then they go to fetch the HTML landing page. And now they hit a different machine. That machine could be on a different schedule. So for example, as we're rolling out new versions of docs, this probably won't come as a surprise to you guys, but we have more than one machine running Google Docs. So as we roll out new versions, not all machines are on the same version. And that's exactly what's happening here. When we hit machine B to actually retrieve the HTML page, it points to my JavaScript binary 456. The worst part about this is that there's no mechanism to stop this. The server will have to return 200s for all of this, which from its point of view, it served everything correctly. The browser will see everything returned properly, so it says my app cache is up to date. It won't retrieve a new app cache until there's a new push. So that could be, a week. So that user won't be able to use their offline application for that week, because as soon as they get to the landing page, it will point to a JavaScript binary which doesn't exist offline, because they're pointing to 1, 2, 3, and they only have 4, 5, 6 offline. So they explode. And exploding is a problem. So there are actually a few solutions that are possible here. Does anybody have any ideas? Has anybody bumped into this before? Did I hear a yes out there? Yeah. So what was your solution, or if you're willing to share it?
After running to it, I made sure that the URLs don't change anymore.
Okay.
I also run a JavaScript that checks for an update in the manifest like every 30 seconds.
Okay.
Maybe a different problem.
That's a related problem. So his solution was to make sure that didn't change, the URLs didn't change. That's definitely one solution, and that's something that we wanted to do, but we decided against it. And the reason is you get a lot more cache hits if the binary is always the same name. So for example, if you have my JavaScript binary 1, 2, 3, you can say this expires a dozen years from now, so that the client never has to refetch the binary. And we weren't willing to undo some of the optimizations that having a hash in our JavaScript and our JavaScript binary name would do. Does anybody else have any ideas? All right, well, I'll throw some out there. So you could download multiple binaries. You could say, I'm going to download JavaScript binary 1, 2, 3, and 4, 5, 6. The issue is that we have to know beforehand when we're going to update to 4, 5, 6. So before a push, we would have to tell all existing machines, hey, the next JavaScript binary is going to be 4, 5, 6, so download both of them. And that's sort of crappy. Plus, the user's going to have to download a lot more JavaScript binaries, and it's just not the cleanest approach. So you could put the binary into the landing page. Instead of having an external JavaScript binary, just inline it. The difficulty there is really performance. That's really what it boils down to. It also deviates from the online case, and we really wanted to keep the online and offline flows similar. So performance is a problem because we dynamically execute our scripts to ensure that only when we need something does it get pulled in. So the user is able to edit a document before all of the JavaScript is even downloaded. So we could put binary into a comment and then evaluate that comment. So this is actually what other people do. This is a fairly common pattern, and this is one that we were really considering. The problem is it will deviate from online and offline. And the online case, we don't want the user to have to download 2 megabytes of an HTML page before evaluating a comment. And we really did want that hard barrier there. So you could version landing pages. So the other thing you could do is, instead of having // page or /edit, you could have /edit 1, /edit 2, and /edit 1 will map to my JavaScript binary 1, 2, 3. My edit 2 will map to 4, 5, 6. The issue is then all applications then have to know, oh, I have to hit /edit 2 instead of /edit 3 or instead of /edit 4. And getting that coordination right between all the different editors, or between the fallback application, which actually loads it, and the push is kind of complicated. Which leads us to intercept entries, which is what we ended up going with. So who here is familiar with the Chrome-specific, as far as I know, Chrome-specific concept of intercept entries in the app cache? Awesome, I'm going to teach you something new. So Chrome-specific app cache entries allow you to intercept URLs using a prefix match before they hit the network. So how do we use it? We can say URL returns URL2. So in this case, what we can do is we can append that version. So we can append that version, but have /edit redirects that version. In other words, we can have, in the explicit entries section, we can have /page given that version, either through a query parameter or however you want to append it to that URL. Then we can have that intercept entry say /page always forwards to /page with that version attached. So how does this work? Why does this work? So what ends up happening is the browser will actually try to download /page with the given version. If it hits machine B, if we go back to our diagram and it hits machine B, it's going to say, I don't know what that version is, and it's going to send back a 404. The browser's going to get that 404, and it's going to say, well, this app cache update was a failure, so let's throw this away. And then it does it again. So if the machine that you hit is on a different version, if the machine that you hit when retrieving the app cache manifest is on a different version than the machine that you hit when you actually retrieve the landing page, it just won't update. The app cache will not update. So this is guaranteed to work, which is pretty neat. And it requires no difference between the online and the offline flow. We can still use /page when online. We don't have to append a version number to it. So why this talk? So I have just a few minutes left, and I really want people to think about offline. It's best for you, and it's best for your users. If the stuff that you work on is available for your users all the time, they will be much happier than if it's available to them only when they have a connection. I'm sure people here, despite how connected we seem to constantly be, have experienced network outages, been on a plane, etc. So web apps and traditional apps are fairly similar, except now web apps can take advantage of all the benefits of the cloud plus go offline. And I think that we've really demonstrated it with Docs Offline. I also wanted to point out some of the things that made it hard for us, like matching static content to the landing page. That's something which earlier offline things like, dare I mention it, Gears, actually did right. And in the app cache world, that's been difficult for us to do. And it can be done. So think offline. Whenever you construct something, make sure that whenever it goes to server, just send it to local store as well. Then read it back from local store. So I have a few minutes left. So I wanted to thank you all for coming and sitting through my talk. I didn't know if anybody had any questions about any of the things that I've discussed. And I'll also be available at the Google booth after this. So feel free to visit us. We're in the lunchroom. Yes.
Hey, so with the intercept rules, was that something that you put into Chrome because Docs required it, or is it something that Chrome put in and then Docs discovered it? Like, is there a feedback loop, or?
That is an excellent question. So the answer is we discovered it. So if you take a look at the history of it, intercept entries were added sometime last November in the newest version of Chrome Nightlies at the time, and we took advantage of it at some point in June, something like that. So that was innocent of us. Other questions?
Kind of a follow-up to this one. Are you pushing that to standard bodies to get, because that sounds really useful, but then it only works on Chrome?
It is incredibly useful. So that's something that we leave up to. So there was a talk earlier today in this room about pushing stuff to standards bodies, and it takes a lot of time. So that's something that we have been pushing for. There are a couple of things that are slowing that down, but this is something that we're pushing for. We think that it's an excellent improvement to every browser. If it's one of the things, along with getting permissions from the Chrome apps and background pages, etc., that are preventing us from doing Docs Offline cross-browser. Right now it's Chrome only. So pushing this through standards will make Docs Offline work everywhere. That's the better for us. So that's definitely something that we're pushing for. Other questions?
I think that's it. I think that's it for now. If you have any more questions, Kevin will be at the Google booth inside. But thank you very much, Kevin.